Hi, so in this video I'm going to be talking about 7.4, which is addition and multiplication rules of probability. I know that we didn't really have enough time in class to actually cover this, so I'll try to be thorough when explaining this to you. We'll go over the general rules and definitions and stuff in the beginning, and then I'll go into examples. So in this chapter, we're going to be thinking about the probabilities of certain events happening. And there's two key things that we'll be looking at. So event A happening or event B happening, and event A happening and event B happening. These are our two different events. And this distinction does matter because if you could look at a person and say, this person goes into this list if they are a girl and they are wearing a blue shirt, or if they are wearing a blue shirt. Boys who are wearing a blue shirt would go into here. Girls who aren't wearing a blue shirt would go into here, and girls who are wearing who are both a girl and wearing a blue shirt would go onto our list. However, if it was girl, so that gives us at least three different possibilities. But if it was girl and blue shirt, then you would only have one of those possibilities on that list because she'd have to be a girl and she'd have to be wearing a blue shirt. So the very small wording of or and are what's sort of making a big difference. So the addition rule of probability is that the probability of event A happening or the event B happening is the probability of A. So let's say that you wanted to roll either a 1 or a 3 or a 6 on a 6-sided dice. We know that the probability of rolling a 1 is 1 in 6. We know that the probability of rolling a 3 is 1 in 6. And we know that the probability of rolling a 6 is 1 in 6. We're going to add all of these together. So the probability of getting a 1, 3, or 6 is going to be 3 out of 6, or 1/2. So that's basically it. The probability of the first event happening plus the probability of the second event happening, and then minus the probability of A and B happening. So for an example of this, there will be examples with marbles. And we could say that we have 3 blue marbles and 2 red marbles. And we have 2 blue and red marbles that share. And then let's say we have just 3 green marbles. There are 10 marbles in total. And we want to know the probability of drawing a blue marble. A blue or a red marble. So there's 1, 2, 3, 4, 5 blues. So 5 out of 10 for blue. I should have done that in blue. 5 out of 10 for blue. And there's 4 out of 10 for red. But these two are sharing. So we need to minus the two, the two mixed marbles from each other. So this will give us 7. There's a 7 out of 10 chance of pulling a red or a blue. Because if we had just kept this 5 and 4, that would give us 9 out of 10. But then we still have these. So it'd be, it wouldn't make sense because we have more than 10 marbles in that case, but these two share. So that's what this minus part is about. The addition rule for mutually exclusive events is basically when there's an and in our equation. So if we wanted to roll a dice 3 times in a row, and we wanted to get a 1 the first time, a 3 the second time, and a 6 the third time, there's a 1 in 6 chance of rolling a 1, there's a 1 in 6 chance of rolling a 3, and there's a 1 in 6 chance of rolling a 6. However, we can't just add these together because this happens each time. So we actually have to times them each time, which will give us 1 over 216. Because we're just timesing straight across, right? So the probability gets a lot more tricky when there's an and involved. So yeah, like rolling I was doing the multiplication rule, not the addition. That was for down here. My bad. When we're talking about probability, there's a couple of more concepts. So mutually exclusive events, and independent and dependent variables. So mutually exclusive events are like when A and B cannot happen at the same time. So you cannot roll both a 1 and a 6 on a dice in one roll. Like you roll it, you either get a 1 or a 6. You can't get both at the same time. It doesn't work like that. Or living in the city or the country. You cannot live in both the city or the country at the same time. You only have one person and only one body. You can't split yourself. So things like that. When we're talking about addition, we don't need to worry about minusing. Addition with mutually exclusive events. We don't need to worry about the minusing because it already takes care of that. In the marble example, there would not be any marbles that are a mixture of red and blue. It would just be red or blue. In that case, it's just the easy 1 plus 1, like 1 over 6 plus 1 over 6. So we just covered this, I guess. Independent events are events where the result of one event does not influence the probability of the other. So, for an example, if you roll a 1 on a dice, you still have a chance of rolling a 1 the next time you roll. However, if you had 3 cards, and one of them was a heart, one of them was a diamond, and one of them was a club, and you took the diamond one away, and you didn't put it back, the next time you draw a card, it's dependent on the first event that happened. That would be a dependent event where it matters. The other, when you take it out and don't replace it, it affects the next probabilities. So it would, if you were replacing the cards, it would still be an independent event. Like if you took the diamond out on one turn and then put it back in the card, you still have a chance of rolling, like picking a diamond. We just went over the multiplication for independent events up there with the multiplication because I misread. I was saying for, I don't know, I misread. But yeah, conditional probability is when, so conditional probability is basically when we're thinking about, like with that last card example, where it's basically an independent event again. When we are, it's basically the probability of something happening after something happened before. Like if you take this card out, there'd be a 1 in 2 chance of drawing the other 2 instead of 1 in 3. So sort of in, once you figure that out, calculating the probability of 2 dependent events happening together, it's pretty straightforward. And that is the multiplication rule for dependent events. It's basically saying, with this card example, if we had a hearts, and we had a club, and we had a diamond, and we wanted to know the probability of a heart being drawn, and then a club being drawn, and the heart is not replaced, and a diamond being drawn after that. So there's a 1/3 chance a heart will be drawn, and then after that, there's a 1/3 chance, a 1/2 chance of a club being drawn, and then a 1/1 chance of the diamond being drawn. And so that would give us a 1 out of 6 chance of drawing them in that order, because we are taking out the different cards, if that makes sense. You basically just need to minus it by 1 each time when you're taking stuff out. So those are like the definitions and stuff, but it's kind of hard to deal with definitions if you don't really know how they apply. So we can get into some of the examples here. It says Mr. Weber's, Mr. Weber's business class has 102 students, classified by academic year and gender, as illustrated in the table. Mr. Weber randomly chooses one student to collect yesterday's work. What is the probability that he selects a male, given that he chooses randomly from only the juniors? And then we want to express it as a fraction. So he's only choosing from juniors. We don't need to worry about this here. We want to find out how many juniors there are, because he's only choosing from the juniors, and that would be 17 plus 18, which is 35. So there's 35 juniors in total, and there's 17 males. So it's going to be 17 over 35. That's going to be our probability, if that makes sense. This next one is telling us that a bag of 11 marbles, so there's 11, has 5 marbles with red in them, 5 with blue, 5 with green, and 2 with red and green. And, well, actually, drawing them out is a little bit tricky for these because it doesn't tell you if there's any that share blue. So if I drew this out, there'd be 13 marbles, because it's hard to tell, which is still more than 11. So we just have to deal with the numbers rather than the pictures. So we have these marbles, and we want to find out the probability that a randomly chosen marble has either green or red on it. And these events are not mutually exclusive. So we know that 5 of them, so there's a 5 out of 11 chance that it's red, a 5 out of 11 chance that it's green, and we know that it's going to be minus 2 out of 11 because of our rule before. So 5 plus 5 minus 2 is equal to 8. So 8 out of 11. That should be our answer. 8 out of 11 chance. Especially since it's saying or. Green or red. This one is telling us that 3 cards are drawn with a replacement from a standard deck of 52 cards. It will tell you what is in 52 cards. I won't go over that. Find the probability that the first card will be a spade, the second card will be a red card, and a third card will be a face card. And it's saying with replacement, so we don't need to worry about minusing anything. So the first card, the chance of it being a spade is 13 out of 52. And then the chance of the second card being a red card is going to be 26 out of 52. And the chance that the third card will be a face card is 12 out of 52. And when we do this, we get, when I plugged that in, I got 3 over 104. When you're multiplying and stuff. Another example is, it's asking us to take so a single letter from the word Tennessee is chosen, and it's asking for the probability of choosing an E or a T. So there's 9 letters in Tennessee, and there's 1 T, so 1 over 9, and there is 4 E's in the word. And it's saying or, so we can just add them together. There's a 5 out of 9 chance that you will pull a E or a T. The last example I have is asking us to select all of these situations that contain independent events. And it's asking us to select all that applies. The first example is the favorite fruit of 5 randomly selected shoppers in the produce section of a grocery store. Let me see. When we think about this, it's probably independent because their answers do not depend on what the other person answered. The second example is saying that pulling a blue marble from a jar and then pulling a second blue marble from a jar after replacing the first marble. This replacing word is important. Replacing it makes it an independent event because it doesn't affect the second pull. The third example is winning a marathon and winning the local lottery. These are also independent events. because you winning a marathon does not affect winning the lottery. And then the last event is pulling a red marble from a jar and then pulling a second marble from a jar without replacing the first marble. This is a dependent event because your first event, pulling the red marble from a jar and then not replacing it, affects the probability of the second event. Yeah. If you have any questions, please let me know. I know that it's sort of new and it's sometimes hard when Keith isn't the one to introduce it because he's really good at explaining things and sometimes I ramble. But yeah, if you have any questions, please let me know. Have a good one.